1.5 linear equation inequalities. So we're going to be solving linear equations with one variable. Now we saw this like you normally would simplify and try to get the x's on one side and numbers on the other side. So let's start. Simplify this real quick. I get 10 plus 6x minus 12 equal to, should be this negative 17 minus x minus 5. Now again, generally with the linear equation, you want to put all the x's on one side and all the constants on the other side. I'm going to simplify first though. So like 10 plus negative 2, 6x minus 2, when you combine these two. Over here, I combine these two and I get 12 minus x. Right, so now let's move the number over that side, let's move this variable over this side. So plus 2 plus x, and I get 7x equals 14 divided by 7, x equals 2. So, solve a linear equation. You can check your answer by substituting it back in and see if it works. I'm going to skip that. How do you do when there's like fractions? The general idea is if we don't want to deal with fractions. So what we want to do, the easiest way is multiply everything by the LCD. Lowest common denominator. So you look at this, you get, and I made that a fraction, so it's 1, 2, and 6. What's the smallest thing that goes into 1, 2, and 6? And that should just be 6. Because 2 and 6 both go into 6. So we'll multiply everything by 6. So let's look like this. So multiply this by 6 over 1, 6 over 1, and 6 over 1. So over here, the 6's just cancel out, and I get x plus 7. Over here, 6 and 2 reduce. I could reduce that, and I get 3. So multiplying all this by 3. So I'll just write that for now. And on this side, it's just, nothing cancels, it's just negative 4 times 6. Which again, I'll just write like this for now. Simplify later. So then we distribute x plus 7 equals 6x minus 24 equals negative 24. This should be I don't know why I put an equal sign here, it should be a plus sign. There we go. Anyway, simplify, let's go. Get 7x. 7 minus 24 is negative 17. Equals negative 24. So then we add 17 to both sides. And I get 7x equals negative 7. So divide by 7. X equals negative 1. Right, so it's just a shortcut to like, what do you do if you have fractions? Well, no one likes fractions. Multiply everything by the LCD and you get rid of your fractions. Then a similar idea down here, what happens if you have decimals? Again, no one likes working with decimals. So we could do the same concept. We can multiply by 100 or 1,000 or 10 to get rid of all these decimals here. So what you want to do is just count how many spots behind the decimal you have. Like, what's the max number? So 2, 2, 2. So all I need to multiply by is 100. Because that will clear out all the decimals. If one of them was like a 3 or 4, I might have to multiply by 1,000 or 10,000. But they only have 2 decimal spots, so multiply them by 100. So just like we did last time, we're going to multiply this guy by 100, this guy by 100, and this guy by 100. 100 times 0.06, this gets us 6x. When you multiply and it's 3 things, remember you only multiply pairwise first. So you can multiply these two first, and that gets me 9 times 15 minus x. It doesn't distribute because there's no plus or minus. It just, like this would distribute here. But here, you multiply these two and they just come together and get 9. There's still the 15 minus x. And on this side, same idea. You're just going to get 0.07 times 100 to get to 7 times 15. And now it's a normal problem. Just got to solve like we normally would. Whoops. Distribute 6x plus 90 plus 45 is 135 minus 9x equals 70 plus 35, so 105. Right, and then we just simplify it, add like terms. Negative 3x plus 135 equals 105. Subtract 135 from both sides. So you want to get the numbers and the variables on separate sides. I get negative 30 divided by negative 3. And yeah, x equals 10. So, right, the last two is just showing you like if you have ugliness here, how do you make it less ugly? If you have a fraction, multiply by LCD, makes it nice. If you have decimals, multiply by 100, like factors of 10 that make the decimals go away. All you have to do is count what's the biggest, which one number has the most number of decimals, and use that to get rid of it. Now let's talk about how to do it with the calculator. If I want to solve the equation with a calculator, So if you have an equation like this, where you have a function equals another function, just like we have up here, right? Yeah, this equation equals that equation. This equation, it's kind of hard to see, but this equation equals that equation. This equals that. One way of solving your calculator is you just graph both of them. So we'll have this equation be f of x, that equation be g of x. And when you graph two equations, one of three things happens. They intersect, and you get your solution right there. Now keep in mind the solution will be the x value. Since you're graphing, the x value is my solution. We could get parallel lines, and parallel lines don't cross, so you get no solution. And they could turn out to be the same graph, and if it's the same graph, you get infinitely many solutions. So these are your three options. Most of the time it's going to be they intersect at a certain spot, so your x value is your solution. You might get parallel lines, and you might get them to be in the same line, you get infinitely many solutions. So for example, let's say I had two equations I graphed and I got this. All I want to do here is find out what the solution set is. So all we're looking for is where does it cross? Right there. And then remember, I got to find the x value. Now you don't have to actually look and go, is it 1, 2, 3? This is from the calculator. So they actually tell you down here, the intersection is 1, 3. And again, all I care about is the x value, so it's x equals 1. That's my solution. Right? If you graph it, it's just where they cross, what's the x value? Because that's where your solution is. So let's do one ourselves now. This is an application problem talking about the sales of cassette tapes versus sales of compact discs over the years between 1987 and 1999. And we want to figure out when these two things match. When did the compact disc sales, the tape sales, match the CD sales? So we're going to graph it. We want to figure out when f of x equals g of x. And instead of solving this by hand, we're going to use a calculator. So I'm going to bring out my calculator right here. And what to solve this with the calculator is we're going to make one side y1 and the other side y2. So we're going to graph it. So I'm going to hit y equals, and then we're going to type this in, 5.91 x plus 13.7. And then over here, negative 4. Now again, when it's in very front like this, you use a negative sign, not the subtraction sign. So negative 4.71 x plus 64.7. Then we're going to hit graph. I got to fix my window. I'm going to go zoom standard. Zoom 6 is a normal window. So if you have like you saw with me, I had a funky window. You generally want to start with zoom standard, and we might have to fix it later. Like I have to fix now. So here, I only see one graph cross. And it looks like, I'm guessing it'll be 13.7. I don't see the other one at all. So we have to fix our window here. Now we can do it ourselves. If we look in the key to doing that yourselves, you want to look at the y-intercepts. Right, so my y here only goes to about 10. I gotta go all the way to 67, so I might want to go my window all the way to like, I like to give myself a buffer, like all the way to like 80 maybe, so I could see things. My y min negative 10, that's gonna be fine, I guess. X man, we'll see if that works. I might have to expand the x value also. But notice I'm at the top 80 now, so I can see what's going on. Now you can see the top one here. There's g of x, and there's my graph. This one, draw a little sketch so people can see what's going on, right? And we want to find that guy right there. So how do I do it on the calculator? We're going to find intersection. We want to hit calculate. It's right here in blue. It's the second button, so it's second trace. We don't want to hit trace. Traces along, but that doesn't give you an exact value. You want to hit the calculate button. Let it do the work for you. So hit second calculate, and we just want to find the intersection, number 5. So you can press 5, or you can go down, hit 5. And the way this works is this. It says first curve or second curve. Like it's asking, is that the first curve? When you go left or right, you move along the curve. When you go up or down, it switches between the curves. So it doesn't matter, whichever one you want it to be the first curve, it does not matter. You just want to get close to what the intersection is, hit enter for first curve. It's like, okay, yeah, that's my first curve. Then you can see it jumps down to the other curve. It's like, is this your second curve? Generally, you just press like, yeah, enter, second curve. Then it's like, do you want me to guess? Yeah, guess. Like, which is this? Do you want me to go through the mathematics to figure out where it's at? It's an approximation. That's why they say guess. And you do that, and you get your answer. We'll round it to nearest 100th most of the time. So 4.80. So x equals 4.80. Now, if I'm going to solve this application problem, remember 0 responds to 1987. So 1987 is 0. So 88 would be 1. 89 would be 2. 90 would be 3. 91 would be 4. So this is between the year 1990. 1 in 1992. That's when CDs overtook compact sales. Well, when were they equal? They were equal sometime in 1991. Remember, it's an application problem. So during the year 1991 is when they were equal. Now there's another way to solve using your calculator. It's called the x-intercept method, and it's exactly what it sounds like. What happens here is you only have one equation. Instead of having two equations like we had here, right? We had set one equal to another. What if we only have one equation and it equals 0? So when you have one equation equals 0, so like for example, 2x minus 4 equals 0. The way you solve that is just finding the x-intercept. So that's the other way to do it. If you only have one equation, you set equal to 0, and then you find the x-intercept. So in our example right here, so there's my x-intercept. And again, you don't need to do it by yourself. The calculator tells you there's a 0, also known as the x-intercept. It's 2. Something like that. So this is an example. Now here's this thing. Here's example 5. They already have the answer. Like they let you know it's -2, but they want to show it by using the x-intercept method. So now x-intercept method kind of sucks if it's not already there. You want to set equal to 0. Now I know if I solve this, I'll do y1, y2, but they want us to do the x-intercept method. So I got to set this guy equal to 0. So I'm going to subtract off 5x minus 4. I'm going to add 10 to this side. So it's going to look kind of disgusting. 6x minus 4, 3 minus 2x, minus 5 times x minus 4, plus 10 equals 0. I should probably do it down here so you can see it all in one go. Right, the general idea if you want to do the x-intercept method is set equal to 0. So there we go. That's the x-intercept method. Set it all equal to 0. Then on your calculator, we're going to type that in for my y equals. Clear those two off. Go up there. I'm going to type that all in. So 6x minus 4 times 3 minus 2x minus 5 times x minus 4 plus 10. So I typed that all in there. I don't put anything for y2 and hit graph. Now again, my window's a little funky because of what I did last time, so I'm going to actually stop and put zoom standard. So I can go back to the normal -10, 10. See, I feel more at home already. So there's my 0. There's my x-intercept. That's my solution. Now again, I already know it's -2, but they want to show it. So how do we do it on a calculator? So to show you how we do the x-intercept method, we graph it. So there's my graph. That's a little different than finding the intersection. So if you go to the same area, we want to calculate something. So you go tag and calculate. Instead of finding the intersection, what I'm looking for here is a 0. Looking for the 0. So I'm going to hit number 2, 0. And then it says left bound, right bound. So what's going on here is this. If that's my 0, the calculator doesn't know it's a 0. So it has to search for it. So what they want you to do is tell it what the left bound is. So like give it a little search window. So what I'd like to do is like to go to the 0 and then move a little left or right. Now on this, as you can see from my calculator, I don't know where my little like marker is. You don't see it. They tell you down here though. Right now you're at 0, so I'm right here. So to go to my 0, to get to that guy, I gotta move left. If I move it left enough, you'll see it. So there it is. So again, if you ever can't see your little marker, they tell you in the bottom left corner. Oh, it's at 0 right now, which is right here. So I gotta move left to get to where I want to go. Just press enough, and there you go. So this is the thing I talked about. If I'm trying to find the 0 right here, it wants a left bound. So what I'm going to do is just get close to it and hit left a couple times. So like right there is fine. That's going to be my left bound. And all you have to do is hit enter. And then it wants to know what the right bound is. So now you have to go to the right of it. So go to your 0 and hit right a couple times. So that'll be a right bound. Now what the calculator is doing is going to search in between these two values to find the actual intersection. So when I hit enter, right, it's like, okay, that's right bound. It doesn't want you to guess. It just means, again, do you want me to go through the mathematics to estimate the answer? That's why it's a guess. You hit enter, and then it does it, and it finds -2. I guess that was the last problem. This problem is x equals -2. So that's the way it goes. So that's how you find your 0. So if you do the 0 method, it's a little more work. You gotta go second calculator. You find the 0. and then you go a little left of your 0, hit enter, and then you go back to your 0 and go a little right of your 0, hit enter. That gives a nice searching window. Then you press enter again, and it finds it for you. So 2 ways to solve with your calculator, right? If you have 2 graphs, just find the intersection. If you have 1 graph, then you're looking for the x-intercept and you have to find the 0. Okay, let's talk about how to solve inequalities. Solving inequalities is very similar to solving the equations. You do it the exact same way. The one thing you gotta worry about is we have an inequality. If you multiply or divide by a negative number, you have to flip the inequality. So then that is all kind of the same. The multiplication property still exists. These are different versions of it. The one thing you gotta remember is that if you multiply or divide by a negative, you have to flip the inequality. So let's solve the inequality by hand first. So let's do this real quickly. Solve it just like a normal thing. So 3x, normal equation, minus 4x, minus 8. Remember, distribute this to both of them. That's equal to 2x plus 1. And then we're going to do something easy. We're going to simplify and then try to get all the variables on one side. Now, oops, that's bad math. It's negative 1. I would say a couple things. When you solve an inequality, in that case, you want to keep the variable on the left-hand side. It makes the graphing much easier. So keep in mind, if you have to multiply divide by negative, you have to switch inequality. If you're solving, you generally want to keep the x on the left-hand side. This makes your graphing inequality much easier. So let's add 8 to both sides. We're solving this. Subtract 2x. So I get negative 3x less than equal to 9. And then right here, I have to divide by negative 3. So since I divided by negative 3, it's going to flip my inequality. That guy's going to become greater than or equals to 2 sign. And there's my answer. And typically they want us to graph this on a number line. So you just go, don't have to be special about this, but that's negative 3. It's a closed circle because of the equal to sign, and it's going to the right. So there we go. If I wanted this in interval notation, I'd just be like, oh, that's a bracket from negative 3 to infinity. Right, stuff like that. I think this is the number line, though. Let's solve another one. Now this one has a fraction. So what did we talk about before? If you want to get rid of fractions, it's multiply with LCD, which in this case is just negative 3 is only one fraction. So we'll multiply both sides by negative 3. Now again, I multiply by negatives, so I have to flip my inequality, so don't forget that. But let me distribute negative 6x plus 9 greater than, because again, I multiply by negative. Over here, these cancel out, and you just get x plus 2. Let's solve it. Like I say, I like to keep when we solve inequalities, I keep the variable on the left-hand side. So let's subtract 9 from both sides, and let's subtract this x from both sides. So I get negative 7x is greater than negative 7. I can divide by negative again. Negative 7, negative 7. These cancel out. I do got to flip that guy though. So x is less than 1. And then draw a number line. It's an open circle this time, and we're going to the left. Right. No equal to sign, so open circle to the left. And again, there's a little bonus. If I was going to do this in interval notation, this would be negative infinity, because it's an arrow, so infinity, and it's going to the left. And then this will be 1 with a parenthesis, because it's not closed. So that would be my answer. Graphical approaches to solving linear inequalities. So how do we solve linear inequality? Sorry about that. So, as this is right here, as a solution of fx greater than g of x is a set of all numbers of x such that f is above g. When something's greater than it, that means you're above. So right, if I say, like it says there, if I say f is greater than g, then f should be on top. If I say f is less than g, the thing should be on the bottom. Right, it's like reading a book, you're going from left to right. So the thing on the left hand, if it's greater than, that's the one on top. The thing on the left hand is less than, that's the thing on the bottom. Now look at here, I'm just gonna split it up. Right, let's look at this side right here, less than x equals 2. The one on top here is x squared. Oh, sorry, y squared. y2. So right here, I would say y2 is greater than y1. But you can always say also y1 is less than y2, right? Because y1's on the bottom. So if you think about it that way, you say y1 is less than y2, or you can say y2 is greater than y1. On this side, look which one's on top. y1 is. So I would generally say y1 is greater than y2. But you could also say y2 smaller. So you'd be like, hey, y2 is smaller than y1. Or the general idea is the thing on the left is the thing you're talking about. So is this thing bigger or smaller than the thing on the right? So the left is the thing you're talking about. So we want to solve this inequality. We're going to solve this using our calculator. So we're not going to do this by hand like I did the last one. We're going to do this with our calculator. So I'm going to bring my calculator back. Try to turn it on. It's been a while. Go to y equals. We're just going to do y1, y2. So y1 is going to be this guy. And I want that to be less than or equal to y2, which is this guy. So y1 is 3x minus 2 times 2x plus 4. And then down here will be 2x plus 1. Again, we're going to graph it. Now, I have an old calculator, so it doesn't. There's no color here. The first thing you graph is the one that is the y1, and the second thing is y2. So when you go here, the first thing graphed is y1, second thing graphed is y2. If you have a more updated calculator, that you can have different colors, and your life's nicer. So for me, this is y1. So I like to draw it here so in general so you know what people are talking about. So it looks like this. It doesn't have to be a perfect sketch, just an idea. So this is my y1, this is my y2. Right? And I want to know, when is y1 less than y2? So the key thing here is right here, is the inflection point, our nexus point. It's right there, right? That's where things change. So before this value right here, which I have to figure out in a second, but before this value, y1 is on top. y1 is greater than y2. I want y1 to be less than y2, so it's after this value. So from here on, y1 is less than y2. So from here on, from like here all the way to here, that's when my y1 is less than my y2. That's when it's below the y2. Because remember, this is all y2, this is all y1. I should have done different colors. Anyway, I do got to figure out what that point is. How do we figure it out? We find the intersection. So we're going to go second, calculate, find the intersection. Remember, all we have to do is get kind of close to it. Remember, if you're not sure where you're at, it tells you right here. You're at 0. So I need to go left to get to here. You just want to get kind of close to it, and then hit enter a couple times. Enter, enter. It has that -3. So my answer here, when is y1 less than y2? It is from -3 all the way to infinity, to the end time. That is my answer, from -3 all the way to infinity. Now, actually -3 should be a bracket because it is an equal to sign. So that should be a bracket. So that's how I do interval notation. I guess you always do set builder and say x such that x is greater than -3. That also works. You can also do it that way. But the general idea here is, right, -3 is kind of like the nexus point. Before -3, y1 is greater than y2, which is not what I want. I want y1 to be less than y2. So that's what I want y1 below. So after -3, y1 is below y2. And there's that one. Okay, let's talk about how about 0. Just like before, this is when we have only one equation. So when we have one equation, we're always relating it to 0. So when we're talking about 0, remember, 0 is the x-intercept. So this is 0. Right, so now if I give you a graph, when is this graph greater than 0? And when is that graph less than 0? Well, just like before, greater than is reading from left to right. So greater than would be when it's above 0. So in my picture here, it would be from here on. Like this is when I'm above 0. So it would be from this guy all the way to here. And then when you're below 0, when you're below it. So it would be when you're less than 0 is when you're below it. So it would be over here. So it would be less than 0. So that's what you see here. Right? You find the x-intercept. Here's my f of x. This is f of x above 0, all right here, from this value all the way to infinity. And it's below 0 from here to here. If a graph happens to be going down, well, when is f of x greater than 0? Right here, right? This is where you're above the y-axis, x-axis, and it's already below it. So let's do an example. Solve this inequality using the x-axis, x-intercept method. Why are they doing this to us? Okay. X-intercept method, again, is when it equals 0, so they want one equation. So I got to move this guy over. So we're going to get -2 times 3x plus 1 minus 4 times x plus 2. Again, only because they want the x-intercept method. Normally I just do y1, y2, when is this guy less than this guy? But they want the x-intercept method, so I'm doing this. I think normally that's just way too much work for no reason. Anyway, but to show you how to use the x-intercept method, we're going to do this. Anyway, we have that. And then we have to go to the graph. And again, we're only going to graph the one side. So I put them all on the same side over here. We're going to graph that. So I need somewhere to write it. -2, 3x plus 1, minus 4 times x plus 2. And we're going to graph that. Again, it's only one equation, it's only y1, right? So again, I like to show the graph so we all know what we're talking about. So it looks like this. It looks something like that. I want where my function f, let's just say y, is less than 0. Right? That's what I'm looking for. I'm looking for my equation. It's my equation y. I want that to be less than 0. So when is it below the x-axis? So from here on, right? From here on. So I gotta figure out what the point is. And just like before, we're gonna find, I gotta find that 0 there. So I'm gonna go second, calculate, find the 0. Remember the way the 0 works? Right now I'm at 0, so I'm right here. I gotta go left to get to my 0 there. You just want to go a little left of it to give it a left bound. And then go back to your 0 and go a little right to give it a right bound. And then it's going to search between those two values. That's going to be -1. So when is my solution here is, when does this function less than 0? From -1 on. Now in this case, it's just a less than sign, not an equal to sign, so it's just -1 to infinity. Or if you're doing set builder, x such that x is greater than -1. So something like that. So again, when you have one equation, less than means you're below the x-axis, greater than means you're above it, because 0 is the x-axis. Okay, last one, compound inequalities. So that's when you have an and statement, you can combine the two inequalities. So like you see here, you have 2x plus 1 is greater than -3, but also 2x plus 1 is less than 2. So you can kind of combine it. This thing is less than 2 but greater than -3, you can move the -3 to like right here. And you get this guy. That's a compound inequality. And just to show you, the way you solve these normally is whatever you do to one side, you gotta do to all sides. So you want to start at the middle here. And you're just trying to isolate x. So you just want to get x by itself. So we're going to subtract 1, right? So what I do here is I'm going to subtract 1 from all portions, right? Subtract 1 from the left side, from the middle side, from the right side. And then you get -4 is less than 2x is less than or equal to 1. And then I still have the 2 there. Well, divide everything by 2. So I divide this by 2, I divide that by 2, I divide that by 2. So I get -2 is less than or equal to x, less than or equal to 1/2. And to me, this is the easiest graph to do, like using solution set to do. Because all you do is do a number line. Here's -2, here's 1/2, and I'm in between these two guys. And that's all you have to do for a number line there. Okay, so let's do this last one here. Solve a compound inequality. We're going to do two ways. I'm going to show you how to solve it analytically like we just did. That's what we did. And show you how to do it with the graphing calculator. Which in this case is probably not as easy. But anyway, let's do it analytically first. So -2 is less than 5 plus 3x less than 20. So just like before, I'm trying to get this x by itself, so I'm going to get rid of all the fluff around it. So let's subtract off the -5. And you can see I do it to every single section here. Right, so do the middle section, left section, and right section. You get -7 is less than 3x is less than 15. And I saw the 3 from the x, so now I'm going to divide everything by 3. I get -7/3 is less than x is less than 5. And that is my answer. If I want, generally they want you to draw a number line. Again, don't over stress it. Let's just do this. Open circle, because there's no equal to sign, and then connect them. X is between these two things, right? X is always the line you're not when you do the number line. So X could be anything between these two values. This is a general idea. Now how do I do that with the calculator? Now with the calculator, what happens here is you make this 3 equations. You make this y1, y2, and y3. So that's how we're going to do this with the calculator. So let me bring out my calculator. So you go to Excel. It's probably a little more complicated with the calculator than it should be. But we're going to make 3 equations here, -2. Again, since it's in front, I'm going to do a negative, not a subtraction sign. Then we do the middle, 5 plus 3x. And then we're going to do 20. Now, I'll tell you right now, notice how 20 is like big. 20 is bigger than 10. My normal window is -10 to 10. I'm not going to be able to see 20. So I'm about to change my window already. So I'm gonna go to window. I want to be my max should be at very least 20, but I don't like you want to give yourself buffers so you actually see 20. So I'm gonna put 30 down so I could see the 20 pretty clearly. So there you go. There's -2. There's 5 plus 3x, and then there's 20. So we got that graph. Let me draw it here so you have a reference to it. I'll explain what we do next. Okay, this is just so we can see what's going on. So this is y equals -2. Again, it's not a perfect graph. It's just trying to get you an idea. This is 5 plus 3x, and then this would be 20. So the question here is, look what it is. When is 5 plus 3x, which is this horizontal line, in between, when's it less than 20 but greater than -2? Like basically when's it in between the two values? And that should be from here to here. Right? That's when it's in between these two values. Right here, 5x plus 3 is greater than both of them. Right here, 5x plus 3 is less than both of them. When it's in between, when it's in the Goldilocks zone, right here. So all I gotta do is find out what those two values are. And then how do you do that? Well, you go second, calculate, and you find intersections. Now there's two intersections here we gotta find. So first, look, notice I'm right here. You can see me right there. Again, if you want, you could jump up, you skip the curve. So if you're pressing up, you go through all three equations. And it tells you right here what equation you're on. So I'm right here, I'm on this line. If I press up, I'm on that line. If I press up again, I'm on that line. So all you want to do is get close to one of them. So let's get close to this one. Hit enter a couple times. And it tells us intersection is at 5. I guess that wasn't close enough because it gave me this one. So this is at 5. Now I gotta find the other one. So I'm gonna go second, calculate. Second, calculate, intersect. I see, and I know what my problem was. So I went like this, right? Oops. I was like moving close to this guy. When it hits second curve, you see how it jumps up here? So that's why it gave me this one. I actually want to jump to this one, so let me press up. So it goes down to the bottom one, and then I'll press enter. Now it's gonna find it between these two guys. There we go. And I get -2.3. Also known as -7/3. So that's where your x is. X is between, oops, not equal to. X is between 5 and -2/3. So there we go.